Out there, in the quiet dark between the stars, countless travelers move unseen. Some drift for millions of years, carrying the frozen memories of places we may never visit. Every so often, one of these wanderers crosses our path, slipping into the glow of our sun for only a brief moment before vanishing back into the endless night. It makes us wonder, what hidden stories drift through that vast darkness? And what would it feel like to stand on such a lonely fragment of another world? What exactly is 3I Atlas? Why does it look so different from the comets we know, surrounded by a strange halo of carbon dioxide, unlike anything we've seen before? And could it be more than just a comet? Could it even be something crafted, a piece of alien technology silently gliding between the stars? Welcome to Sleep Time Discoveries, where we explore mysteries like these in a calm and unhurried way. If you'd like to join us again for more journeys into the quiet wonders of the universe, you can subscribe. And it's always comforting to know where you're listening from tonight. Let us know in the comments below. So now, let's begin. Tonight we turn our attention to 3I Atlas, a rare visitor from beyond our solar system, unlike anything we have seen before. These are the very questions astronomers themselves are asking about one of the rarest objects ever observed. A traveler that does not belong here, a fragment of another star system, carrying with it the quiet secrets of unimaginable distance and time. 3I Atlas is the name given to this object. The 3I means it is the third known interstellar object, the third time humanity has ever observed something drifting into our solar system from the depths of interstellar space. The first was Oumuamua in 2017, the second was 2I Borisov in 2019, and now this new arrival, 3I Atlas, discovered in 2024. Unlike the countless comets that circle the Sun, 3I Atlas did not form here. It was not born in the icy outer edges of our solar system. Instead, it comes from somewhere far beyond, another star system, perhaps even another region of our galaxy. That is what makes it extraordinary. It is a fragment of another world, a piece of material from beyond the Sun's family of planets, moons, and comets. From the very first observations, astronomers realized something unusual was happening. The object's path across the sky was not the looping curve of an orbit. It was not circling the Sun the way asteroids and comets do. Instead, its trajectory was a sharp hyperbola, an open path that showed it was only passing through. It was moving too fast to be captured by the Sun's gravity. This meant only one thing. It came from interstellar space, and it would eventually leave again. But how was it first noticed? 3I Atlas was first detected by the Asteroid Terrestrial Impact Last Alert System, better known by its acronym ATLAS. ATLAS is a survey project designed to scan the skies for near-Earth objects that might pose a danger to our planet. It consists of a network of wide-field telescopes, constantly watching the night for anything new, faint points of light that shift position against the stars. In 2024, one of these telescopes picked up a faint moving object. At first, it seemed to be just another comet. The software that scans images flagged it, and astronomers logged it for further observation. But as more measurements were taken, the motion didn't fit. The object was moving unusually fast. Its orbit didn't close back on itself. Instead, the calculations showed a steep hyperbolic curve, the unmistakable sign of an interstellar visitor. Almost immediately, the astronomy community took notice. Whenever something this rare appears in the sky, it sparks a wave of excitement. Observatories around the world turn their telescopes toward the faint smudge of light. Professionals and skilled amateurs alike wanted to be part of studying it. Data poured in from different observatories, each confirming that this was indeed a new interstellar traveler. And then came the first surprise, its brightness. Unlike Oumuamua, which remained strangely dim and showed no visible coma, 3I Atlas displayed the fuzzy glow of a typical comet, but with peculiar properties. Spectral data showed an unusually high abundance of carbon dioxide gas streaming from it. Compared with water vapor, the ratio was about 8:1, far beyond what is normal in solar system comets. This made it stand out immediately. What kind of comet releases so much carbon dioxide and so little water? The discovery was quickly passed along to the Minor Planet Center, the international body that collects data on new objects. There, it was given its official designation, 3I/2024 A3ATLAS, but most simply call it 3I Atlas. The 3I marks it as the third interstellar object known to humanity. The name Atlas honors the telescope system that first detected it. Once the news spread, comparisons with Oumuamua were inevitable. That first interstellar visitor had stirred up enormous debate. Its elongated shape, unusual acceleration, and lack of a cometary tail led some scientists, including Avi Loeb of Harvard University, to propose that it might even be artificial, perhaps a fragment of alien technology. Though controversial, the idea captured the public imagination. Now, with 3I Atlas, the question surfaced again: could this also be more than just a comet? Astronomers rushed to gather as much information as possible. The James Webb Space Telescope was pointed at the object, offering unprecedented detail. Its powerful infrared instruments revealed that 3I Atlas is surrounded by a dense, extended halo of carbon dioxide. This coma was thicker than expected, hiding the nucleus from clear view. It was as if the object carried a veil, shrouding its true surface from observers. The discovery was both fascinating and frustrating. On the one hand, the measurements confirmed that 3I Atlas is unlike any comet we have studied before. On the other hand, the thick shell of gas prevented scientists from seeing what lies beneath. Is the nucleus an icy ball, like ordinary comets, or could it be something unexpected? The truth remains hidden behind its carbon dioxide mask. Meanwhile, orbital calculations began to reveal the object's past. Its trajectory suggested that it came from the thick disk of the Milky Way, a population of stars older than the Sun. That meant 3I Atlas could be 7 to 14 billion years old. If so, it would make this comet older than the solar system itself, possibly formed when the galaxy was still young. Think of the implications. This object began its journey before Earth existed, before the Sun ignited, before the planets formed. It has been traveling through interstellar space for longer than life has existed on our world. For eons it drifted in silence, passing by countless stars, wandering through the galaxy until, by chance, it crossed paths with our solar system. The reactions among astronomers were a mix of excitement and humility. Rarely do we have the chance to study something so ancient and so alien to our solar system. Interstellar visitors are like time capsules, carrying material from places we may never reach, shaped by environments we may never see. They offer glimpses into other planetary systems, into the chemistry of other worlds. But they also raise questions that science cannot yet answer. Why does 3I Atlas have such an unusual chemical composition? How could a comet so ancient still release gas in such abundance? And of course, the question that captures the imagination of so many: could it possibly be something artificial? Though the majority of scientists lean toward natural explanations, the mystery remains. Each interstellar object we discover challenges our assumptions and reminds us of how little we truly know. So, in the early months after its discovery, 3I Atlas became more than just another entry in the astronomical catalogue. It became a story of a traveller from beyond, a story that asks whether we are alone in the universe, and a story that connects us to the vast, unseen history of our galaxy. For now, we see only the surface mystery. A glowing traveller, shrouded in carbon dioxide, speeding past our sun on a path that will soon carry it away forever. A brief visitor that will leave behind more questions than answers. And so, the arrival of 3I Atlas marks not just a discovery, but the beginning of a new chapter in our understanding of the cosmos. A reminder that even in the quiet of the night sky, strangers can still appear, carrying with them secrets we may never fully uncover. What exactly sets 3I Atlas apart from everything else we've ever seen in the sky? Why does this visitor not behave like the comets we have studied for centuries? And why do astronomers whisper that it may be one of the strangest messengers our solar system has ever welcomed? At first, it appears unremarkable. To the eye of a telescope, it looks like a pale blur drifting across the dark, no brighter than countless other comets that sweep in from the frozen edges of space. But with every closer look, 3I Atlas reveals traits that refuse to fit the patterns we know. One of the very first surprises came from its chemistry. Astronomers often describe comets as dirty snowballs, mixtures of frozen water, carbon-based ices, rock, and dust. When these objects draw near the sun, their frozen layers begin to vaporize, and the escaping gas creates the glowing halo, the coma, that surrounds them. Normally, this halo is dominated by water vapor. Carbon dioxide is often present, but only in smaller proportions. That is the rule our comets follow. 3. I-Atlas breaks this rule dramatically. When the James Webb Space Telescope turned its instruments toward the comet, it found something astonishing. For every 1 molecule of water vapor, there were almost 8 molecules of carbon dioxide, an 8-to-1 ratio. To put that in perspective, no comet we have ever studied in our solar system shows such a composition. Here at home, water always outweighs carbon dioxide, but 3I-Atlas comes bearing an entirely different recipe, as though it were born under foreign conditions. Why is it like this? Did the comet form in an extraordinarily cold part of another star system, where water was locked away early and carbon dioxide became the dominant ice? Or is this imbalance a signature of something even more exotic? To scientists, this lopsided chemistry feels like an alien fingerprint, a reminder that other star systems may build their comets from ingredients unlike anything familiar to us. The strange carbon dioxide halo does more than mark 3I-Atlas as unusual. It also hides it from us. Most comets, once observed closely, allow at least fleeting glimpses of their solid nucleus, the small rocky heart inside the haze. But 3I-Atlas refuses. Its shroud of carbon dioxide is so dense, so extended, that the nucleus remains invisible. Astronomers cannot measure its exact size, its shape, or even its surface structure. It is as if we are watching a traveler stride past in heavy fog. The glow, the outline, the motion are there, but the figure itself stays concealed. This thick veil raises its own questions. Why is the gas so abundant? Is the nucleus unusually volatile, pouring out material at an extraordinary rate? Or does it possess cavern-like reservoirs of frozen carbon dioxide that release in great plumes as it warms? The longer it hides, the deeper the speculation becomes. A veil can conceal something ordinary, or it can conceal something extraordinary, and in this case, we cannot be sure which. The mysteries of 3I-Atlas go beyond chemistry. They extend to its origins and its age. Astronomers tracing its path backward through the galaxy believe it comes not from a nearby star system, but from the thick disk of the Milky Way. This is one of the oldest regions of our galaxy, populated by stars that formed billions of years before the Sun. If 3I-Atlas truly began its journey there, it may be older than our solar system itself. Its age is estimated somewhere between 7 and 14 billion years. That means this fragment of ice and dust may have existed long before Earth was born, before the planets, before our Sun even ignited. Imagine an object drifting silently for nearly the entire history of the galaxy, surviving collisions, cosmic rays, and countless eons in the interstellar dark, until chance finally brought it here. To study it is to peer backward through time, to touch something that remembers an era before our world. This makes 3I-Atlas not just another comet, but perhaps one of the oldest travelers humanity has ever observed. A relic older than the oceans, older than the continents, older than life itself. Of course, this is not our first encounter with something from beyond. In 2017, astronomers detected the first interstellar visitor, Oumuamua. Its elongated cigar-like shape, its lack of a visible coma, and its strange, unexplained acceleration defied all expectations. Some argued it was a comet shedding invisible gases. Others dared to suggest it might be artificial, perhaps a fragment of alien technology, or even a light sail. The debate has never truly ended. 2 years later, in 2019, came 2I/Borisov. This time, the object behaved more like a traditional comet, with a visible tail and familiar chemistry. But its interstellar path made it clear that it too had come from another star system, a frozen messenger carrying its own story. Now comes 3I-Atlas, the third interstellar visitor. In some ways, it seems like Borisov, with its coma and cometary activity. But in other ways, it resembles Oumuamua, wrapped in mystery and defiance of our categories. Its carbon dioxide veil sets it apart from both. It is neither fully familiar nor entirely alien, but something in between. Each interstellar traveler so far has presented its own puzzle, and 3i Atlas may be the most perplexing yet. And as always, when faced with a puzzle like this, the human mind wanders to possibility. Could it be something artificial? Could the unusual composition and heavy gas release be a disguise? Could the hidden nucleus beneath the shroud be something not carved by nature, but by design? Most scientists stop short of such conclusions. The evidence so far suggests a natural origin. The enormous release of carbon dioxide is strange, yes, but not impossible for an icy body born under the right conditions. Still, the thought lingers, unspoken yet irresistible. What if? What if the veil is not just a natural process, but a deliberate mask? What if, beneath the gas, something waits that we cannot yet imagine? Whether artificial or natural, the effect is the same. 3i Atlas forces us to re-examine the rules we thought we understood. We thought comets were water-rich. Here is one rich in carbon dioxide. We thought they would reveal their nuclei up close. Here is one that hides itself completely. We thought interstellar visitors would be rare beyond imagining. Now we have seen 3 in less than 10 years. Each time the universe whispers to us, "Your knowledge is not complete." And so we wonder, if you could drift alongside 3i Atlas in the vast emptiness of space, what would you see? Perhaps a rough, icy surface beneath the gas, cracked with ancient fissures from billions of years in the dark. Perhaps the ice would shimmer faintly, catching the sunlight in a way no earthly ice ever could. You might watch the gas streaming off in silent plumes, glowing faintly as it disperses into the vacuum. If you stood upon it, though of course its gravity is too weak for that, you would feel the silence pressing in on every side, the endless black stretching forever. You would know that under your feet was a body that had travelled longer than human history, older than the Earth itself, carrying secrets from an age before time as we measure it. And still the question would echo, is this only a comet, or is it something more? The answer remains hidden in the fog, drifting with the comet as it glides past our sun. Perhaps we will learn more as it moves on its path, or perhaps it will keep its secrets, vanishing again into the dark, leaving only a memory and a question. But even now, it has already changed us. It has reminded us that the universe is filled with travelers, that other worlds have left fragments adrift, and that sometimes, against all odds, one of them passes close enough for us to glimpse. It has reminded us that mystery still lives among the stars, and that sometimes the unknown is not far away, but just overhead, glowing softly in the night sky. When astronomers first began to calculate the age of 3i Atlas, they were struck by something extraordinary. This was not just another comet drifting in from the far edges of a star system. This was an object that seemed to carry the weight of deep time. The measurements of its speed, the curve of its trajectory, and the analysis of its composition suggested a truth that was difficult to comprehend. 3i Atlas may be 7 to 14 billion years old. Numbers like that stretch beyond what we are used to thinking about. The Earth is around 4.5 billion years old. The Sun, a relatively middle-aged star, is also about 4.6 billion years in age. Even the oldest life forms on our planet, the simplest microbes, only began to appear perhaps 3.5 billion years ago. Civilizations and human history are measured in thousands of years, a flicker in comparison. But here, drifting silently across the darkness, is an object that may be twice as old as the Sun, perhaps even older than the galaxy's spiral arms that now sweep across the night sky. If the lower estimate is correct, 7 billion years, then 3i Atlas was already ancient when our solar system was forming. It was already a traveller when Earth was just dust and gas beginning to coalesce. And if the upper estimate is true, 14 billion years, then this object is nearly as old as the universe itself. For reference, the Big Bang occurred around 13.8 billion years ago. That means 3i Atlas could have been born in the first generations of stars that ever shone, at a time when galaxies were just beginning to take shape. To contemplate that possibility is to reach into a past so deep that it almost defies imagination. Astronomers believe it likely originated in what is called the thick disk of the Milky Way. Our galaxy, like others, has structure, a thin disk where the spiral arms lie, a central bulge filled with older stars, and surrounding all of it, the halo of dark matter. The thick disk is a region populated by some of the oldest stars in the galaxy, stars that formed many billions of years ago when the Milky Way was still young. It is a region of ancient suns, many of them poor in metals, meaning they formed before generations of stars had seeded the galaxy with heavier elements like carbon, oxygen, and iron. If 3I Atlas was born there, it would mean it came from a time and place where the galaxy's chemistry was still raw and simple. What does it mean for us to witness such a traveler? Imagine an object that has been wandering since before the solar system was born, passing near countless stars, drifting between invisible currents of gravity, pulled and released by stellar encounters until by chance it reached our neighborhood. Each collision it narrowly avoided, each system it passed by unseen, is part of its hidden history. It has been sculpted not by one sun, but by the collective influence of many, perhaps dozens or even hundreds of stars it has passed across during its unimaginable journey. As we look at 3I Atlas, we are peering into a fragment of a past so distant that even the galaxies we see in telescopes today do not show us such a history in physical form. We often say that telescopes are time machines, letting us look back into the past by seeing galaxies as they were billions of years ago. But here is a different kind of time machine, not light, but matter itself, a shard of ancient creation arriving into our skies. How does one describe an object older than our sun? Its icy body would have endured the radiation of countless stars. Its surface may have been baked and frozen, struck by cosmic rays, scarred by micrometeoroids, and reshaped again and again. If we could touch it, it would likely be brittle, ancient ice, riddled with fractures and voids. It might release gases not commonly found in younger comets, evidence of chemical recipes written in the early universe. The extraordinary ratio of carbon dioxide we observe is perhaps a fingerprint of its birth environment, a signature telling us this fragment carries chemistry from a different kind of star system altogether. What is fascinating is that this ancient age does not make it lifeless in its story, quite the opposite. Each time 3I Atlas passes near a star, its surface is awakened. Frozen ices sublimate, gases form halos and tails, and for a brief moment, a silent traveler becomes visible. To us, it appears as a comet, but beneath that display is something unimaginably old, continuing its path forward, just as it has for billions of years. It is humbling to realize that our planet has seen only a handful of such visitors. Oumuamua in 2017, Borisov in 2019, and now Atlas. That means in all of human history, we have recorded only 3 interstellar guests. And of those 3, ATLAS may be the most ancient. Out of the billions of years it has traveled, our species happens to exist in the narrow moment when it passes by. The coincidence is almost too great to grasp, and yet, here it is. Its light reflected in our telescopes, its chemistry detected in our instruments, its presence a quiet reminder that the universe is far older, far larger, and far stranger than we can ever fully comprehend. Imagine, if you will, what it would be like to drift alongside it, to leave the solar system and follow Atlas as it continues on its way. You would move at tens of kilometers per second, faster than any spacecraft we have yet launched, and yet still slowly in the vastness of the galaxy. Stars would pass by over thousands of years, glimmering points that shift ever so gently. Dust and gas clouds would glow faintly in the distance, and Atlas would keep moving, a fragment of ancient ice, heading toward destinations unknown. If 3I Atlas truly has been traveling for up to 14 billion years, then it has already witnessed the galaxy transform. It has seen the Milky Way collide with smaller galaxies, absorbing their stars and reshaping its structure. It has passed through regions of higher density and quieter stretches of interstellar emptiness. Perhaps it once belonged to a star system that no longer exists, its parent star long gone, consumed in a supernova, leaving nothing behind but fragments like this. In that sense, ATLAS is not just a comet, it is a survivor, carrying the memory of a system erased from time. For us, the idea of memory is tied to experience and thought, but in the cosmic sense, memory is material. The ice locked in this traveler is memory. The unusual ratio of its gases is memory. The path it has traced across the galaxy is memory. And by studying these fragments, we are reading that memory, piecing together the story of places and times beyond our own. When we think of how young humanity is, only a few 100,000 years of existence, and how recently we have begun to look at the skies with real understanding, just the last few centuries, the arrival of something so old feels like a gentle reminder. We are latecomers to a universe already in progress. Our species is new, our planet is young, our sun just another star among billions. And yet we are able to witness, to study, to wonder. That is the gift Atlas has given us. As you listen, imagine letting the scale of time wash over you. Imagine Earth forming billions of years ago, while ATLAS was already travelling. Imagine the dinosaurs rising and falling, while Atlas was still making its slow journey between stars. Imagine civilizations rising, writing stories, building monuments, unaware that above them, an ancient traveller was continuing its endless path. And now, for the briefest moment, our paths cross. There is comfort in that thought. We often imagine the universe as cold and indifferent, but here is a connection. Across billions of years, across the light of countless stars, a fragment from another world passes by and we are here to notice. Perhaps someday we will send missions to objects like this. Perhaps we will touch them, sample them, and hold in our hands ice that formed before the sun was born. Until then, we look through our telescopes and we wonder, what would it feel like to be that traveller? To carry the memory of galaxies colliding, of stars dying and being born, of billions of years passing in silence. 3. Atlas does not answer, of course. It simply drifts onward. But in its silence, it leaves us with something to dream about. The knowledge that the universe is more ancient than we can measure, and yet close enough to touch with our minds. And so, as we close this chapter, we do not need to solve every mystery of Atlas. It is enough to know that we are witnesses. That for a brief window in time, we saw a traveller older than our world, and we wondered at its story. That wonder will stay with us, long after the comet itself has passed from view. From the moment 3I Atlas left the star system where it was born, its journey began without intention, without purpose, and yet with a quiet persistence that would carry it for billions of years. Unlike a spacecraft guided by computers or a ship steered by hands, it had no destination. It was simply nudged outward, perhaps through a close encounter with a massive planet or the gravitational disturbance of a nearby star, until its path no longer curved back toward its home. Instead, it stretched into infinity, an open road across the galaxy. Imagine the moment when it first slipped free of its parent star's influence, a frozen body of ice and dust, small compared to planets, yet still carrying the energy to drift away forever. Behind it, a system of planets and debris would continue to circle in rhythm, as they had for millions of years, but Atlas was gone. Its arc had opened wide enough that gravity would not call it back, and so it entered the interstellar medium, the vast emptiness between stars. What is interstellar space like? We often picture it as pure nothingness, but in truth, it is sprinkled with particles, tenuous gas, thin clouds of hydrogen, tiny grains of dust that drift like smoke stretched across light years. For an object like Atlas, these particles are almost invisible. At its incredible speed, tens of kilometers per second, it passes through them as if they are not even there. The distances are so great, the space so empty, that encounters with anything solid are nearly impossible. That is why an object can travel unimpeded for billions of years, moving silently forward without ever slowing down. The silence is what we might struggle most to imagine. On Earth, there is always sound. The hum of wind, the rustle of leaves, the crackle of fire, even the faint hum of cities or the rhythm of waves. But in space there is none. No air to carry vibration, no medium for noise. A TLAS has been drifting in silence longer than all of human history combined. If you were to stand upon it, you would hear nothing but the sound of your own thoughts. The stars would surround you, vast and unmoving, and time itself would seem to stretch. Over the course of its journey, Atlas has crossed distances beyond measure. A single light year is almost 10 trillion kilometers, and the galaxy itself spans over 100,000 light years from edge to edge. When we say it has been traveling for billions of years, what we mean is that it has likely crossed entire regions of the Milky Way, moving between the spiral arms, perhaps passing close enough to stars to see them as bright suns in its sky before moving on again. Each passage would be slow in human terms, thousands of years to approach, thousands more to recede. But from the perspective of the traveller itself, it is a continuous drift, unbroken, unhurried. Sometimes astronomers wonder how many such objects are out there. If we have already detected 3 within only a handful of years, it may mean that the galaxy is filled with countless others, each on its own silent path. Atlas is simply one of the rare ones whose trajectory happens to intersect our view. But for each one we see, how many more pass unnoticed, gliding just beyond the reach of our instruments? The thought adds a quiet mystery. We are surrounded by travellers, yet most remain hidden in the darkness. The chance that Atlas arrived here at all is remarkable. To find its way into our solar system required a precise alignment of motion. It had to pass close enough to the sun's gravity to be pulled inward, yet not so close that it was captured. Its path carried it in just the right way, a fleeting visitor whose orbit curves only once before it drifts back into the stars. Had its trajectory shifted even slightly millions of years ago, it may have missed us entirely, remaining forever unseen. That we are able to observe it now is the result of cosmic timing so exact that it feels almost deliberate, though we know it is only chance. Picture the moment of its approach. For billions of years it drifted unnoticed, but as it drew closer to our sun, its surface began to change. The ices buried beneath its crust started to warm. Carbon dioxide and water vapor began to escape into space, forming the faint halo we recognize as a coma. A tail stretched behind it, delicate and luminous, like a banner carried through the void. After its near-eternal silence, it suddenly revealed itself, as if announcing its arrival to the small cluster of worlds gathered around the sun. To see it through a telescope is to catch only a glimpse of its story. A streak of light across the blackness, faint but unmistakable. And yet that faint streak is the sign of a journey older than we can truly comprehend. Think of how many civilizations might have risen and fallen in the time it has been drifting. Think of how many stars it might have passed, each one shining on it briefly before fading into the distance. It is an object shaped by chance, sculpted by encounters we will never witness, carrying with it a history written in silence. When we speak of distances and timescales like these, they can feel overwhelming. But there is a kind of peace in them as well. Our daily lives are filled with schedules, hours and minutes. We measure our days in tasks and our years in milestones. But Atlas moves to a different rhythm. Its clock is the galaxy itself, measured not in years but in epochs. To think of that is to step outside of the urgency of human time, to rest in the knowledge that the universe unfolds on a scale far grander and calmer than we usually allow ourselves to feel. Imagine floating alongside it, as though you were a companion on its endless path. You would see the stars slowly shift around you, new constellations forming over millennia. Perhaps you would pass close to a nebula where clouds of dust glow faintly in the light of young stars. Perhaps you would move through regions of darkness where no star shines for light years in every direction. And through it all, ATLAS would continue, steady and patient. No destination, only the journey. Some astronomers speculate that objects like ATLAS may one day serve as natural messengers between civilizations. If intelligent life exists elsewhere in the galaxy, they too may study interstellar comets, tracing their paths and learning from their chemistry. Perhaps just as we wonder about its origins, another species in another time will wonder about the fragments that pass through their skies. The galaxy may be threaded with these silent connections, unintentional but shared across all who watch the stars. As it passes through our solar system, Atlas offers us only a short visit. Its speed ensures that it will not remain long. Soon, it will slip past the orbit of the planets, its coma fading, its tail dissolving, until it returns once again to invisibility. Its path will carry it outward, back into interstellar space, and it will resume its journey across the galaxy. Millions of years from now, perhaps it will cross the path of another star, and the cycle will repeat. A brief flare of light, a temporary display, and then silence again. In that way, Atlas reminds us that everything we see in the universe is temporary. Stars are born, burn, and die. Planets form and are destroyed. Even galaxies themselves collide and merge, reshaping over time. But amid this constant change, there are patterns of endurance. A fragment of ice and dust can survive billions of years, longer than mountains, longer than oceans, longer even than many stars. Its persistence is a quiet lesson. Survival is not always about grandeur or strength. Sometimes it is simply about drifting, carrying forward, untouched except by the faintest of forces. As you let your mind follow this traveler, picture the stillness of its path. Picture the blackness of space not as emptiness, but as a vast ocean, calm and endless. Picture the comet as a small vessel gliding across it, leaving no wake, disturbing nothing, simply moving on. There is a kind of serenity in that image, a reminder that the universe holds spaces of deep quiet, places where time flows like a slow river, unhurried and eternal. And when its light fades from our telescopes, when Atlas has gone, the story does not end. It continues, unseen, still on its way. Perhaps one day, far in the future, another world will see it pass and wonder, just as we do now. Perhaps it will cross paths with beings we cannot imagine, who will look at it and ask the same questions we asked tonight. Where did it come from, and how long has it travelled? For us, the answer is not complete, and perhaps it never will be. But we do not need to know everything to feel its presence. It is enough to know that we were here, at this moment in time, to witness a traveller whose journey spans the galaxy. It is enough to let that thought settle into our minds, calming us, reminding us of the vastness and the beauty that lies beyond our world. And so, as Atlas continues its voyage, we too continue ours, for a time walking beneath the same sky. The comet drifts onward, the stars remain above us, and the universe carries on in silence. If you close your eyes and imagine the quiet of its journey, you may feel the peace of that silence as your own, a reminder that even in the immensity of space there is calm, there is stillness, and there is always something to wonder at. When astronomers first notice a visitor like 3i Atlas, the process begins with a tiny point of light. It appears faint, barely distinguishable from the countless stars that fill the sky. But unlike stars, it shifts its position from night to night, moving just enough to reveal itself as something closer, something crossing through our view. This movement is the first clue, and with careful tracking, its orbit can be calculated. By comparing its speed and the shape of its path around the Sun, astronomers can tell whether it belongs to our solar system or whether it has come from somewhere far beyond. That was the case with Atlas, just as it was for Oumuamua in 2017 and for Borisov in 2019. Both of those earlier objects were noticed because their paths did not fit the patterns of comets or asteroids that circle the Sun again and again. Instead, their orbits were open curves, hyperbolas, the mathematical shapes of visitors who come once and then continue onward into infinity. The discovery of Oumuamua was especially surprising. It showed no clear tail, no glowing coma like a typical comet. To some, it looked more like a shard of rock or even a sliver of something artificial. Borisov, on the other hand, behaved much more like a traditional comet with gas and dust trailing behind it, yet its speed told the same story. It was not from here. Atlas now adds to this small but growing family of interstellar travelers. Each one is different, and each one brings us a rare chance to study material that was formed around another star. Imagine if a pebble from a distant shore drifted across an ocean to land on your beach. By examining it closely, you could learn about the landscapes of a place you may never visit. That is what interstellar comets offer us, physical pieces of alien systems, carrying within them the chemistry and history of their birthplaces. The tools we use to study them are remarkable in themselves. Ground-based telescopes scan the skies with sensitive detectors, capturing faint reflections of sunlight bouncing off their surfaces. By breaking that light into spectra, astronomers can identify the fingerprints of molecules, water, carbon dioxide, methane, and more. Each discovery adds a little more detail to the picture of how these bodies formed. And now, with instruments like the James Webb Space Telescope, our view is even sharper. Webb can peer into the infrared, a region of light invisible to our eyes, where the glow of ices and gases becomes clear. With this vision, scientists can compare Atlas not only to our own comets, but also to the theoretical models of how planets and stars come together in distant regions of the galaxy. One of the most valuable things about these visitors is the chance to compare. Oumuamua was dry and puzzling, Borisov was rich in ices, and Atlas seems to fall somewhere in between. With just 3 examples, we already see that interstellar objects are not all alike. They carry with them the diversity of their origins. Some may come from the outer belts of other solar systems, where comets form in cold reservoirs far from their stars. Others may be fragments of larger bodies, broken apart by collisions or pulled away by gravitational encounters. Each one is like a page from a book written in another part of the galaxy, carried here by chance for us to read. There is also a quiet wonder in knowing how rare these opportunities are. For billions of years, Atlas drifted unseen, and only for a short moment does it pass close enough for our instruments to capture it. To catch that moment requires vigilance, a constant scanning of the sky, and even then, luck plays its part. When Oumuamua was discovered, it was already on its way out of the solar system. By the time larger telescopes were ready to observe, it had faded almost beyond reach. With Borisov and Atlas, we had more time, but still only a fleeting window before they returned to darkness. It is a reminder that the universe does not wait for us. It offers glimpses, and we must be ready to notice them. For many astronomers, this is not just about collecting data, but about a larger curiosity. What do these visitors tell us about the galaxy as a whole? If their chemistry matches our comets, it suggests that the building blocks of planets are universal, scattered everywhere among the stars. If they differ, then each system may carry its own unique recipe, its own approach to shaping worlds. And if someday we find something truly unusual, something that does not look natural at all, the questions we ask may reach even further. As you let your thoughts drift with Atlas, imagine the scientists who watch it, late into the night, recording the faint traces of its light. Imagine the telescopes turning, mirrors gleaming, capturing photons that left the comet only minutes before, traveling across space to reach Earth. And then imagine the longer journey, the billions of years that brought it here, the unbroken chain of motion that no telescope could ever witness. What stories are hidden in the dust it carries? What ancient landscapes does it remember? The answers may not come quickly, and perhaps they never will in full. But there is something peaceful in the search itself, in the steady work of piecing together fragments of knowledge, each visitor adding a little more to our understanding of the cosmos. Atlas, Oumuamua, Borisov, 3 names for 3 brief encounters, 3 reminders of how vast and interconnected the galaxy can be. And as Atlas drifts onward, leaving us behind, we are left with both data and wonder. Data that fills charts and papers, wonder that fills the imagination. Together they form a picture of a universe alive with motion, filled with travelers who may pass our way at any time. To think of that is to feel both small and connected, a part of something greater, something calm and enduring. And so the story of these interstellar visitors closes softly for now, with Atlas continuing its long journey into the quiet dark. Somewhere, beyond the reach of our eyes, it carries on, unchanged, while we rest here beneath the stars, content to have seen it, content to wonder, and content to let the night hold us in its silence. When scientists look at an object like 3I Atlas, they must first begin with the most natural explanation. The cosmos is filled with icy fragments, leftovers from the birth of stars and planets, scattered into the cold beyond. Many of these are released into interstellar space by chance, ejected through gravitational encounters or collisions that hurl them outward. So the first possibility is also the simplest. Atlas may be nothing more than a comet, carrying within it frozen ices and dust that condensed billions of years ago around a distant star. Its unusual brightness, its odd behavior, its chemistry that seems slightly different from what we expect, these may all be the result of ordinary variation. Just as no 2 snowflakes are alike, perhaps no 2 comets are entirely the same. Some contain more water, some more carbon compounds, some may even be strangely depleted of elements we usually find. Could Atlas simply be one of those natural variations drifting to us by chance? This explanation feels comfortable, even reassuring. It allows us to place Atlas neatly within the family of cosmic wanderers we already understand. And yet, there is always room for deeper thought. What if its brightness did not come from just ice sublimating in the sun's warmth? What if its peculiar changes in motion hint at something else? With Oumuamua, scientists faced this same puzzle. It moved as though a faint invisible push was acting upon it, not unlike the way sunlight can press gently against thin surfaces. But Oumuamua showed no clear outgassing, no cloud of vapor that might explain the acceleration. This led some researchers, including the Harvard astronomer Avi Loeb, to suggest a far more daring idea, that perhaps Oumuamua was not natural at all, but rather a fragment of alien technology. A thin sail perhaps drifting through space, propelled by starlight. Or maybe a broken remnant of a probe, a shard of something that once had purpose, now abandoned to the currents of the galaxy. The same question lingers quietly around ATLAS. Could it be? Might we, in this silent traveller, be seeing something that is not simply ice and dust? For many scientists, the cautious answer leans toward the natural. Extraordinary claims require extraordinary evidence, and so far, all that we have are points of light, spectral lines, and orbital paths. Nothing yet demands that we abandon the cometary explanation. And yet curiosity lingers. The thought cannot quite be dismissed, for the universe is vast, and the possibility of other civilizations cannot be ruled out entirely. To wonder is not to claim certainty, it is to allow the imagination to step softly where data leaves open space. Consider what it would mean if it were natural. Atlas would then be a gift of perspective, showing us that interstellar comets may carry strange signatures, unlike those we know. It would remind us that our solar system is only one example among billions, and that the recipes for cosmic bodies can vary in subtle ways. We would learn more about chemistry, about planetary formation, about how different stars sow their fragments into the void. Each molecule traced in its light would tell us something about its long, frozen history. In this view, Atlas is a messenger of nature, carrying with it information older than our sun, ready to be read by those who know how to interpret the code. But now imagine quietly, what if it were not? What if, just as Loeb suggested for Oumuamua, we are glimpsing a relic of another intelligence? Not a spaceship in the way we imagine them in stories, but a piece of something larger. Perhaps a probe sent out long ago, meant to drift for millions of years, scanning, recording, maybe even waiting to be noticed. Or perhaps not a probe at all, but a fragment, like a broken sail, a discarded shell, or debris from a structure that once orbited another star. Across billions of years, civilizations may rise and fall, and if they too explore the galaxy, then pieces of their journeys may still be out here, drifting silently. To us, they appear only as faint specks of light in the telescope, yet behind those specks could lie a story of intelligence, of curiosity, of journeys not unlike our own. The challenge is that from so far away, our evidence is always incomplete. We can measure brightness, we can measure speed, we can try to capture the spectrum of light it reflects. But these are like shadows on a distant wall, clues that require interpretation, and interpretation is shaped by our expectations. If we expect a comet, we see a comet. If we allow ourselves to consider technology, we open a door to other possibilities. Neither can be fully proven, at least not with the few interstellar visitors we have glimpsed so far. This leaves us in a state of gentle uncertainty, where both imagination and reason coexist. What would it feel like if someday we found clearer signs? Suppose we detected an object whose surface reflected light in an unusual way, too smooth, too geometric to be explained by ice. Suppose its path suggested control, or its spectrum revealed materials unlikely to form naturally. In that moment, our quiet curiosity would turn into realization, and the knowledge that we are not alone would become more than speculation. Yet even if such a discovery awaits, there is value in the wondering, for it reminds us that the universe holds mysteries greater than our present understanding, and that humility, patience, and open minds are the tools we need most. The debate over natural versus artificial is not new. In the 1960s, when radio telescopes first picked up repeating signals from space, they were briefly considered as possible messages from intelligent life. Those signals turned out to be pulsars, rapidly spinning neutron stars, natural beacons of astonishing precision. The lesson was not disappointment, but wonder. The natural explanation was no less extraordinary. Instead of a distant civilization, we discovered new stars, unlike any we had known. Perhaps the same will be true here. Perhaps Atlas is not a machine, but a comet so ancient, so strange in its chemistry, that it teaches us things just as profound. And yet the other possibility lingers, as soft as a question whispered in the night. Could someone, somewhere, be sending these fragments across the galaxy? Could interstellar objects be part of a network, drifting from system to system, carrying traces of those who made them? If so, we may not recognize them at first. We may need new ways of looking, new instruments, new patience. But even the question itself has a quiet power, reminding us that the universe is not closed, that its mysteries are not finished. For now, the story of ATLAS remains open. It is a point of light observed, measured, studied, and then allowed to drift away into the deep. Its secrets remain partly hidden, its nature partly unknown. But in that uncertainty lies the very thing that makes it beautiful. We can explain it as ice and dust, and learn from that. We can wonder if it is more, and dream from that. Both paths enrich us, both leave us more connected to the stars. As you let your mind drift with Atlas, you might picture it in both ways at once. In one vision, it is an icy shard, its surface cracked and frosted, glowing faintly as the sun warms it. In another, it is smooth, perhaps metallic, perhaps shaped long ago by hands not our own. Both images float together, like overlapping dreams. Which is true may not matter tonight. What matters is that such possibilities exist, and that our place in the cosmos is one of both discovery and wonder. The comet, or the relic, whichever it may be, moves onward, leaving us behind. It carries on into darkness, silent, steady, ancient. And here, beneath the quiet sky, we are left to reflect on it. Was it ordinary or extraordinary? Was it just another fragment of ice, or something more? The answer perhaps will remain with Atlas itself, traveling far from us, beyond the reach of our instruments, into a future we will not see. But that too has a kind of peace. For not every question must be answered at once. Some may linger, waiting for time, waiting for patience, waiting for future generations to uncover. Tonight, it is enough simply to wonder, to hold the image of Atlas in the mind, and to drift with it into the gentle silence of the stars. As 3i Atlas drifts through our solar system, its path brings it closer to the sun, to that central furnace whose light and gravity shape everything we know. The trajectory is precise, calculated through careful observation, and astronomers know that its closest approach will arrive in late October of the year 2025, on the 29th and 30th days. In those quiet autumn nights here on Earth, while most of us go about ordinary life, this ancient traveller will make its briefest encounter with our star. It will sweep in, glowing faintly as the warmth drives gases and dust from its frozen body, and then it will continue on, retreating once again into the cold vastness of interstellar space. This will be its closest moment, and also its most fleeting. The closeness might suggest that this would be the best time to observe it. After all, comets often become brightest when the sun's heat stirs them to life, releasing long tails that stretch across the night sky. But for Atlas, the story is different. Its path carries it near the sun from our point of view on Earth, and so in the very days when it glows most intensely, it will be drowned in daylight. Telescopes that rely on dark skies will struggle, their view blinded by brilliance. Even sensitive instruments in orbit must contend with glare, with the difficulty of distinguishing a fragile cometary glow against the overwhelming fire of the sun itself. For many astronomers, this means that the close approach will not be a moment of great discovery, but rather of frustration, of knowing that the most revealing hours are hidden from view. There is something poetic in this, a sense of mystery preserved. After travelling for billions of years, Atlas passes through our neighbourhood, yet we cannot look directly at it when it comes nearest. We must accept only glimpses from before and after, partial views, pieces of a greater story that remains unfinished. It feels like trying to remember a dream. Fragments remain, but the whole picture is lost just as it begins to form. How many secrets might it whisper if only we could watch during those days? What details of its composition, Its structure, its true origin, are hidden in that brief interval when we cannot see. Such questions remain unanswered, and perhaps that is part of its quiet charm. Already, astronomers plan for the windows of visibility that lead up to late October, when Atlas is still separated from the Sun in the sky. They measure its brightness, its colour, the subtle way its orbit shifts under the push of sunlight. Each observation becomes a thread, woven into a larger tapestry of understanding. And then, as the 29th approaches, the observations thin, the data grows scarce, and the comet moves into light too blinding to study. There is no stopping this. The mechanics of orbits are precise and unyielding. The comet passes where it must pass. We are left to wait, to wonder, and to look forward to its reappearance afterward. Dimmer, receding, harder to find. For those who reflect on this passage, there is a kind of sadness in the thought of a last glimpse. We will never see Atlas again in our lifetime, nor in the lifetimes of countless generations to come. Its path carries it outward, beyond the pull of our sun, back into the interstellar night. To us, this is a one-time encounter, a chance alignment of cosmic paths. What we do not capture now will remain uncaptured, the missed details carried away into eternity. And so, the close approach is not just an astronomical event, it is a farewell. The comet bows briefly toward our star, then lifts away, silent, distant, forever gone. It invites reflection on the nature of time and opportunity. How often do we have only one chance to notice something, to appreciate it, before it is gone? Atlas is not just a comet, it is a reminder that the universe moves according to its own vast rhythms that we may glimpse only for a moment, the ancient dust within it, the frozen ices that have endured since before our sun was born, all of it will pass beyond our reach. We may collect what little data we can, write papers, build models, but the comet itself will vanish into the void, untouched, unmeasured in its fullness. It is a fleeting visitor, one that comes without warning and leaves without promise of return. And yet, there is also beauty in this fleeting nature. The fact that we cannot know everything, that mysteries remain hidden, gives space for wonder. It means the imagination has room to play, to fill in the gaps with questions. What if we could ride alongside Atlas as it passed the sun, feeling the warmth thaw its crust, seeing plumes of vapor jet outward like geysers? What if we could watch as the light glittered on its surface, revealing colors and textures unseen from Earth? What would it feel like to drift beside it, hearing nothing but silence, as it curved gently around the sun's fire before continuing outward? These visions cannot be captured by telescopes, but they live in thought, soft companions to the data we do hold. The timing of its closest approach, in the calm days of late October, carries its own quiet resonance. On Earth, the season changes, leaves fall, nights grow longer, the air turns cooler. In the sky, an object older than all the forests, older than every mountain, older even than the sun, makes its farewell. One cycle of nature meets another. While we step into autumn once more, Atlas continues on a journey that began long before our world was born. The contrast between our brief seasons and its eternal voyage is humbling. We count time in years, in decades, perhaps in centuries. A TLAS counts in billions, in distances measured across the galaxy itself. Our glimpse of it is but a heartbeat in its endless drift. When it emerges again from the sun's glare, it will already be fading. The heat that briefly awakened its ices will no longer sustain, and it will grow dimmer with every passing day. Observers may track it for a while, but eventually even the most powerful telescopes will lose it against the background of stars. At that moment, it becomes invisible not just to our eyes, but to our science. The interstellar traveler returns to anonymity, one fragment among uncountable others, indistinguishable in the darkness. It leaves behind only the record of its passage, numbers written in observatories, images stored on servers, and memories carried by those who turn their gaze toward it. And so, its close approach is not truly about what we will see, but about what we will not. It is about the absence, the unobserved, the mysteries that slip beyond reach. There is a kind of peace in accepting this. Not every visitor must be fully known. Not every secret must be solved. Sometimes it is enough to acknowledge that something extraordinary passed by, to have shared the same sky with it, even if only briefly. Atlas reminds us that the universe is not ours to control. It comes and goes according to its own vast design, indifferent to our readiness, to our wishes for more data, more clarity, more time. This humility is part of what makes astronomy so profound. We look outward, always hoping to capture and explain, but we are small beneath the immensity of the cosmos. Objects like Atlas show us our limits, and at the same time, they deepen our appreciation. The fact that we cannot hold on to it forever makes the moment we do have more meaningful. It teaches us to notice, to value, to reflect before the opportunity slips away. As Atlas bends around the Sun in late October, invisible in the brightness of day, it will trace a path that has been inevitable since the moment it was ejected from its home system, billions of years ago. Every gravitational tug, every collision, every ancient event that set it on its course has led to this brief alignment, this passing through our skies. It will not pause. It will not return. It simply continues, as if fulfilling a script written long before humanity even existed. We are, for this instant, part of its story, even if only as unnoticed observers on a small planet by a small star. To imagine that last unseen glimpse is to imagine the fading of a dream. The comet rounds the Sun, its vapor jets sparkling, its dust spreading into space. Then it turns outward, the light falls off, and it is gone. Future travelers may never cross its path. Perhaps in some distant era, another civilization, far away, will encounter it again. Perhaps they will study it more closely, uncovering the secrets we could not. Or perhaps it will drift forever unseen, carrying its mysteries into eternity. Both possibilities hold a quiet poetry. Whether observed again or not, Atlas continues, timeless, indifferent, steady. As you rest tonight, you might hold that image softly in your thoughts, the silent comet at its closest approach, invisible to our eyes, yet present, rounding the Sun in its ancient journey. You may imagine the warmth of the sunlight on its frozen surface, the delicate shimmer of dust released into the void, and then the long retreat into shadow. There is no need to grasp it fully. The beauty lies in knowing it was here, in sharing the same moment, however briefly. And as it fades, so too can your thoughts grow quieter, drifting into stillness, like the comet itself, vanishing into the calm darkness of space. When astronomers first realized that 3I Atlas was not bound to our Sun, but instead came from the wider galaxy, a natural question followed. Could we ever reach it? Could we send a spacecraft to chase after this wandering traveler, to see its surface up close, to touch what has journeyed for billions of years between the stars? It is a question that blends science with imagination, because in theory the idea is simple, but in practice the obstacles are immense. The comet is moving at a speed far greater than any human-made craft has ever achieved, tens of kilometers per second relative to our Sun, faster than Voyager, faster than New Horizons, faster than even the most ambitious rockets we have built. To catch it would mean not only matching that speed, but also plotting a course with perfect precision, intercepting an object that will never circle back, that will not slow down, that will not wait for us to arrive. Astronomers and engineers have thought about this problem for several years, beginning with the first interstellar visitor, Oumuamua, in 2017. That object passed so quickly that we had no chance to prepare a mission. By the time we noticed it, it was already on its way out, fading beyond reach. The second, 2I/Borisov, gave a little more time, but still not enough. With 3I Atlas, the same limitation applies. Detection comes only a short while before closest approach, and launching a spacecraft within that narrow window is not realistic with today's technology. Rockets require years of planning, construction, and testing. Spacecraft need careful design and navigation. To imagine catching Atlas, we must also imagine a world where we are ready in advance, where missions wait on standby for the moment such a traveler appears. Several proposals have been made, some under the name of interstellar interceptor missions. These ideas suggest that a spacecraft could be launched long before any comet arrives, waiting patiently in space, perhaps orbiting near Earth or placed at a gravitational balance point like the Sun-Earth Lagrange points. The spacecraft would carry powerful engines or large fuel reserves, able to adjust its trajectory at the moment an interstellar visitor is discovered. Instead of trying to build and launch from Earth in a rush, the probe would already be out there, poised like a watchful guardian, ready to leap into pursuit. It is a clever idea, one that solves the problem of timing. But even then, the speeds are daunting. Atlas moves at more than 25 kilometers per second relative to the Sun. To intercept it, a spacecraft would need either to accelerate to comparable speed or to position itself in just the right place along the comet's path. The mathematics is possible. The engineering is not yet within easy reach. Imagine, though, what such a mission could reveal. A spacecraft approaching Atlas could map its surface in exquisite detail, showing whether it is smooth or jagged, fractured or layered. Cameras could watch as gas escapes from vents in its crust, recording how the Sun awakens its frozen ices. Instruments could sample the chemical composition of the dust, telling us what atoms and molecules make up this ancient traveler. With the right design, the craft might even release a small probe to land on the comet itself, anchoring with harpoons or drills, as the Rosetta mission once did with Comet 67P. To stand, even briefly, on the surface of an interstellar object would be to place human technology on something born in another star's nursery. What would it feel like to be there, gazing outward into space, knowing that beneath your feet lies material older than our Sun? The idea invites both awe and humility. But reality is harsher. The surface gravity of such a comet is minuscule, thousands of times weaker than Earth's. To land is less like touching down and more like trying to cling to a drifting iceberg in zero gravity. Any push, any misstep, could send a probe tumbling off into space. The material itself may be fragile, crumbly, full of dust that shifts under weight. It may not even hold together firmly if disturbed. Landing would be one of the most delicate operations ever attempted. Yet, even a flyby, passing close enough to collect high-resolution images and samples from the surrounding coma of gas and dust, would transform our knowledge. It would be enough to touch the atmosphere of another solar system, to capture particles that condensed around a distant star long ago. The speed challenge remains the greatest obstacle. To give a sense of scale, the Parker Solar Probe, one of the fastest human-made objects, moves at more than 150 kilometers per second when it swings close to the Sun. That is faster than Atlas. But Parker achieves this only by diving deep into the Sun's gravity, a path that does not align with chasing comets passing far from the solar surface. Designing a probe that can reach interstellar objects without sacrificing maneuverability is a problem yet unsolved. Some scientists have suggested advanced propulsion methods, such as solar sails that catch the pressure of sunlight, or even lasers that push a tiny craft to incredible speeds. Projects like Breakthrough Starshot dream of sending gram-sized probes to nearby stars within decades. If such technology can be built, perhaps one day an interstellar comet could be intercepted quickly after discovery. The concept is still far from realization, but the seeds are there, waiting for progress to grow. Until then, our encounters with interstellar travelers remain observational, seen from afar, captured through telescopes rather than spacecraft. It is a gentle reminder of limits, but also of possibility. Each time we detect one, we learn not only about the comet itself, but also about what we must do to be ready next time. Perhaps the role of Atlas is not only to carry its own secrets, but also to prepare us for future visitors. By the time the next arrives, perhaps a spacecraft will indeed be waiting, engines quiet, instruments asleep, until the moment the call comes to intercept. Then, humanity will stretch out a hand to meet the ancient messengers of the stars. The thought of riding alongside such a comet stirs a deep curiosity. Imagine standing on its surface, looking upward. There is no sky, only the black of space, studded with unblinking stars. The Sun is a brilliant point, brighter than anything else, casting sharp shadows across ridges of ice and dust. Jets of vapor hiss silently into the void, arching away in graceful curves, leaving trails that form a delicate halo. The ground beneath you is uneven, fragile, perhaps a mixture of hard crust and loose powder. Each step must be careful, for gravity is so weak that a small leap could carry you into space. And all around is silence, perfect silence, broken only by the hum of your suit or the faint tremor of instruments. What would it feel like to know that the surface you touch was once part of another system entirely, orbiting a distant sun whose light may no longer shine? From such a vantage, the universe feels both vast and intimate. The comet is tiny, a fragment, a wandering speck. Yet it carries within it stories of formation, of collisions, of journeys that lasted billions of years. To study it is to connect with the processes that shape not only other stars but our own. Perhaps the molecules within it are the same that seeded planets elsewhere, the same building blocks that, under the right conditions, might give rise to life. To gather even a small handful of dust from Atlas would be to hold a piece of another solar system in our hands, to cradle the ancient ingredients of worlds we may never see.
As we imagine this, we also accept the quiet truth. We cannot reach Atlas itself. By the time we dream of sending a mission, it is already leaving, accelerating outward, too fast to follow. What remains is the hope for the future, the readiness to act when the next interstellar traveler arrives. And so, Atlas becomes part of a longer story, not just of comets, but of human aspiration. Each one we miss is both a loss and a lesson, guiding us toward the day when our technology, our planning, and our curiosity align.
For now, telescopes watch, data is gathered, papers are written, and imaginations are stirred. The question remains open, lingering softly in thought. Could we ever reach it? The answer today is no, not yet. But in that not yet lies potential, the quiet space where possibility rests, waiting for us to grow. It may be decades or centuries before we succeed, but the stars will wait and the comets will continue to drift. Somewhere in the future, a spacecraft may indeed chase one down and perhaps even land upon it. When that happens, it will not just be a scientific triumph, but also a human one, a moment of connection with the larger galaxy we call home. Until then, the best we can do is imagine. Imagine the craft sailing through the dark, matching speed with a lonely comet. Imagine the moment of approach, when cameras open their eyes and reveal a new world of ice and dust, shapes never seen before. Imagine the delicate dance of landing, the first grains of alien dust touched by human tools. These visions may be dreams, but they are dreams rooted in possibility, and they carry us forward, giving meaning to the patient watch we keep on the sky. As you close your eyes tonight, you might picture yourself drifting beside Atlas, watching its faint glow fade as it moves farther from the sun. You cannot stop it, you cannot hold it, but you can share in its journey, if only in thought. The universe is full of such travelers, unseen and silent, passing through, each one a reminder of the vast connections between stars. We may not catch this one, but the idea of reaching out remains, gentle and steady, guiding us to the future. And in that thought there is peace, the kind of peace that comes from knowing we are part of a story larger than ourselves, a story still unfolding, carried by comets that cross the spaces between the stars. When astronomers speak of 3i Atlas, they often describe it in numbers, its orbit, its velocity, its brightness, its distance from the sun. Yet beyond those numbers lies another way to think about it. The comet is a visitor, not from our own solar system, but from the greater galaxy. It is as though the stars have sent us a messenger, a quiet traveler carrying with it the record of its birthplace. What message does it bring? That is the question that lingers as we watch it glide through space. Perhaps its very presence is the message, proof that the galaxy is not a collection of isolated stars, but a vast, interconnected sea where fragments from one system can wander freely into another. To imagine Atlas as a messenger is to think about what it carries inside. A comet is more than ice and dust. It is a frozen time capsule, preserving the chemistry of the place where it formed. Our own comets tell us about the early solar system, about the ingredients that shaped Earth and gave rise to oceans, air, and life. But an interstellar comet preserves a different story, one written around another star. The ices within it may hold molecules uncommon in our system, or combinations of elements that reflect a slightly different balance of conditions. It might contain clues to how stars in other parts of the galaxy formed their planets, how they distributed water, how they mixed organic compounds. By studying it, even from afar, we are peeking into the history of a distant nursery of worlds. The galaxy itself is old, billions upon billions of years. Stars are born in great clouds of gas, live for millions or billions of years, and eventually die, returning their material to space. In this cycle, comets are cast adrift, thrown out by the gravitational tug of giant planets, flung into interstellar space where they wander indefinitely. Atlas is almost certainly one of these. Long ago, perhaps hundreds of millions or even billions of years in the past, it orbited a star that once shone bright somewhere in the Milky Way. That star may still exist, or it may have faded, or exploded, or drifted far from the place it once was. Atlas is the relic, the survivor, the remnant carrying within it the chemical signature of that lost world. To hold even a small piece of it would be to hold a page torn from the book of galactic history. Scientists can read such messages even from afar. By watching how Atlas brightens as it approaches the sun, by measuring the wavelengths of light it reflects or absorbs, by examining the gases it releases, astronomers can detect which molecules are present. Perhaps it will release cyanides, or carbon monoxide, or methane, or water vapor, or more complex organics. Each detection adds to the catalogue of galactic chemistry. If the mix resembles our comets, we learn that the building blocks of worlds may be similar across much of the galaxy. If the mix is different, we learn that diversity in chemistry is part of the cosmic story. Either way, the message is valuable. It tells us not only about Atlas, but about the galaxy itself, how stars and planets and comets form across the great distances of space. There is also the possibility that such an object might carry materials we have never seen before, not in the sense of magical or unnatural things, but in the sense of compounds rare in our solar system, or stable only under conditions that did not occur here. Imagine if Atlas held exotic ices, frozen at temperatures colder than any in our early nebula. Imagine if it contained a unique isotope ratio, a balance of atoms that reveals the specific kind of star that forged them. These are subtle signatures, quiet but profound. They are the fingerprints of the galaxy's past, written into the frozen body of a comet no larger than a mountain. Even without touching it, just by analyzing its spectrum, we might glimpse such hidden stories. That is the quiet power of treating Atlas as a messenger. It speaks not in words, but in wavelengths, not in sentences, but in the chemistry of ice. Of course, the idea of messages from the stars can invite softer, more poetic thoughts as well. For countless generations, humans have looked upward and wondered what lies beyond. Comets themselves were once seen as omens, carriers of meaning, lights that appeared suddenly and stirred both fear and awe. Today we know them as natural objects, but the sense of mystery remains. An interstellar comet takes that mystery further. It does not belong here. It comes from somewhere else, reminding us that the sky is not fixed, that the galaxy is alive with motion and exchange. Perhaps then, Atlas reminds us that our solar system too is not separate. It is part of a greater whole, part of a network of stars and worlds connected by wandering fragments. What does it feel like to think of the galaxy not as something distant, but as something flowing through us, delivering tiny emissaries from its far corners? The thought is both humbling and comforting. When we imagine Atlas carrying unknown materials, we might also imagine what role such comets could play in the story of life. On Earth, it is possible that comets once brought organic molecules, the seeds of life's chemistry. If this happened here, could it also happen elsewhere? Could comets like Atlas, cast from one star system, carry such seeds across the galaxy? If so, then life's building blocks are not confined to one place, but are shared widely, drifting from star to star. Perhaps Atlas is not only a messenger of chemistry, but also a messenger of potential, a reminder that life may not be a rare accident, but a common possibility woven into the fabric of the Milky Way. We cannot know for certain, but to wonder is natural, and it opens the mind to gentle possibilities. In this way, ATLAS stands as a symbol. It is small, faint, and fleeting. Yet, in its passage, it connects us to cosmic scales of time and space. It whispers of stars long gone, of planets unformed, of histories written in atoms and ices. Its message is not urgent, not loud, but soft, waiting for us to listen carefully. If we do, we may find that the galaxy is less mysterious than it seems, and at the same time, more wondrous than we imagined. As Atlas fades into the outer darkness, our thoughts naturally turn backward to the first messenger that ever passed through, the object called Oumuamua. It was in 2017 that astronomers first spotted it, sliding past the Sun on a hyperbolic orbit. Unlike Atlas, Oumuamua did not behave like a typical comet. It showed no obvious tail, no bright coma of gas. Instead, it was elongated, tumbling oddly, reflecting light in ways that puzzled observers. For some, it resembled a shard of rock. For others, it seemed almost like an artifact, a thin, flat object pushed by the faint pressure of sunlight. It was the first sign that interstellar visitors could surprise us, showing forms and behaviors we had not expected. The lessons from Oumuamua and Atlas together form a kind of dialogue. Oumuamua showed us that interstellar objects exist and that they may not resemble our familiar comets at all. Atlas confirms that some of them do look comet-like, with bright tails and escaping gases. Between them, they expand our picture. The galaxy sends not one type of messenger, but many. Some are icy, some are rocky, some may blur the line between the two. To study them is to learn not only about distant systems, but also about the diversity of planetary formation across the Milky Way. What kinds of worlds give birth to such fragments? What events cast them outward into the interstellar sea? Each visitor provides another clue. From Oumuamua, we learned caution and humility. We had little warning. We could only watch it recede, never to return. From Atlas, we learned preparation, the importance of being ready, the idea that future missions must stand waiting if we wish to catch one. From both, we learned patience because the galaxy does not send such objects often. Perhaps only once in a decade or once in a generation will one pass close enough for us to see. That rarity makes each one precious, each one a chance to learn something we could never learn otherwise. In this way, our curiosity grows in steps, from Oumuamua to Atlas to whatever may come next. What ties these encounters together is not just science, but a sense of continuity in human wonder. Long before telescopes, people watched the sky and wondered what comets meant. Today we use instruments and calculations, but the wondering remains. We still ask, where did it come from? What does it carry? Could it be something more than ice? These questions are ancient in spirit, even if modern in form. They connect us across time, showing that the stars have always drawn us to imagine beyond the known. Perhaps then, the greatest lesson of Oumuamua and Atlas is that discovery is not an end, but a beginning. Each visitor raises new questions, leading us onward. Oumuamua taught us that interstellar objects can be strange. Atlas teaches us that they can also be familiar, yet still profound. Together they remind us that the galaxy is dynamic, full of movement, full of exchanges we are only beginning to notice. Future objects will add more lessons, more voices to the quiet dialogue between stars and observers. As you think of this, you might imagine the continuity not as a line, but as a thread woven into a larger tapestry. Each comet, each fragment, is a stitch, a small piece of a larger design. We may not see the whole picture yet, but we can feel its texture, sense its pattern forming slowly. The tapestry is the galaxy itself, ancient and vast, and we are learning to read it one visitor at a time. What would it feel like to live long enough to see not just one or two, but dozens of such interstellar comets, each studied up close by spacecraft? What kind of understanding would we have then, not just of our own solar system, but of the Milky Way as a whole? The thought drifts softly, like a dream, far away but within the realm of possibility. For now, we look back with gratitude. Oumuamua startled us, opened our eyes. Atlas steadies us, teaching patience, offering lessons in chemistry and preparation. Both are part of the same unfolding story, and as they fade, they leave us not with answers carved in stone, but with questions gentle enough to carry into rest. The messages from the stars are never loud. They are quiet, distant, shimmering in the night sky. They remind us that we are part of something vast, that curiosity itself is a bridge between the known and the unknown. And in that reminder, there is calm, there is peace, and there is a sense of belonging within the great and mysterious galaxy we call home. The journey of 3i Atlas has carried us far, and now, at its end, we return once more to the question that has lingered since the first moment it was spotted through a telescope. What was it, truly? An icy fragment, born in the cradle of some distant star system, flung into interstellar space by chance and shaped by the same natural processes that formed countless other comets? Or something rarer, something more deliberate, a vessel built by intelligence designed to endure the dark between the stars? These two possibilities remain with us, like two quiet paths stretching out into the unknown. As we close this story, it is time to walk them both, gently, carefully, without rushing, without demanding certainty, but simply exploring what each means for us. The natural explanation begins with abundance. Comets are not rare jewels, but the scattered remains of planetary formation. When a young star is born, a disk of dust and gas surrounds it. Within that disk, particles collide and cling, forming larger and larger bodies. Some grow into planets, massive and stable, but many remain small, icy, fragile. They drift on the edges of the system, in the deep cold far from the warmth of the star. Their ice is preserved for billions of years. Our own solar system holds such regions, the Kuiper belt beyond Neptune, and farther still, the vast Oort cloud, which may contain trillions of icy fragments. Most remain unseen, too small and too distant for our telescopes to detect, but their existence is supported by every comet that falls inward toward our sun. If such structures exist here, it is only reasonable to believe they exist around other stars as well. The laws of physics do not change from system to system. Wherever planets form, comets are formed too, as natural byproducts. Over time, the gravity of giant planets can fling some of these icy objects outward, ejecting them entirely from their home star. Once free, they drift endlessly through interstellar space, unbound to any system, until one day, by sheer coincidence, they cross paths with another star. Our sun is one such destination. In the vastness of time, it was inevitable that some of these wanderers would pass near us, and in our brief age of powerful telescopes, we have been fortunate enough to notice them. When Oumuamua was discovered in 2017, it was the first proof of this expectation. Then came Borisov in 2019, unmistakably comet-like, confirming the pattern. By the time 3i Atlas appeared in 2020, astronomers were not surprised. Rather, they saw in it a continuation of a story already begun. Interstellar objects are real, they are common, and they may pass us far more often than we once imagined. The behavior of 3i Atlas strengthened this view. It showed a bright coma, a diffuse cloud of gas and dust surrounding its nucleus, just as comets in our own system do when heated by sunlight. It displayed a faint tail, a stream of particles pushed away by the solar wind. Even its breakup seemed familiar. Comets are fragile, prone to shattering as the sun's warmth cracks their icy cores. In every way that could be observed, 3i Atlas fit within the category of natural comets. Nothing about it demanded a more unusual explanation. To most astronomers, this was enough. The simplest conclusion was also the most likely. It was a comet, born of another star's debris, a traveller by chance rather than by design. And yet, even as the evidence leaned toward the natural, the possibility of something more never fully disappeared. Perhaps this is because of Oumuamua, whose unusual acceleration and elongated shape raised questions that science has not fully answered. If one interstellar object could defy easy classification, then others could too. In the case of 3i Atlas, no strange behaviour was confirmed, but the imagination cannot be so easily quieted. What if, hidden within its icy shell, there was more than dust and frozen gas? What if, deep inside, it carried structures we could not detect, fragments of design from a civilization we do not yet know exists? It is not a claim, but a question, one that belongs more to reflection than to proof. To imagine 3i Atlas as artificial is to imagine a civilization so ancient and far away that its creations drift across the galaxy without ever expecting to be found. Perhaps such a civilization might launch probes not to return, but simply to endure, carrying pieces of knowledge, signals, or even monuments of existence. Such probes to survive might be built to look like comets, to use the very materials of space as protection. To us, observing from a distance, they would be indistinguishable. They would reflect sunlight like ice, break apart like fragile stone, and yet inside, perhaps, they might carry a different story. Could such a thing exist? The probability is unknown. Most scientists would say unlikely, and with reason. There is no evidence to suggest that 3I Atlas was anything other than natural. But the value of this possibility lies not in proof, but in the way it stretches our vision. To hold even a small space for the idea is to remember that the universe is vast enough to surprise us, and that our tools may not yet be sensitive enough to reveal every truth. What we call a comet could be something else, hidden in plain sight, waiting for a future generation to recognize. When we balance these two perspectives, the natural and the artificial, we find that neither cancels the other. One offers the comfort of understanding. Comets are common, and 3I Atlas was one of them. The other offers the invitation of wonder. If not, then what else might it have been? Together, they remind us of something deeper, something that does not depend on the final answer. Whether a fragment of ice or a creation of intelligence, its passing draws our attention outward, beyond the borders of Earth, into the spaces where questions matter as much as answers. And so, as this chapter closes, we are left with reflection rather than resolution. The universe has given us a glimpse and then taken it away. 3I Atlas has returned to the darkness, continuing its endless journey. We will never see it again, and we may never know its full nature. Yet in the silence it leaves behind, there is meaning. It reminds us of our smallness, yes, but also of our curiosity, of the way we reach out with telescopes and imagination to touch what is otherwise unreachable. To stand beneath the night sky and think of it is to feel both humility and peace. Humility because we are so small compared to the vastness of interstellar space. Peace because even in our smallness, we are capable of wonder. The mystery remains open, not as a burden, but as a gift. It is the open mysteries that keep us looking upward, that keep us asking, that keep us connected to the cosmos around us. And so the story of 3I Atlas ends softly, without a final answer, but with balance. Most likely, it was a natural comet, one of countless others drifting between stars. But perhaps, just perhaps, it was more. The truth will remain hidden, carried away into the dark, beyond our reach. What remains with us is not certainty, but perspective. A reminder that the universe is vast, that mysteries still pass us in the night, and that the act of wondering is itself a kind of connection. In that quiet balance we find our closing, not with noise or conclusion, but with stillness. The traveller is gone, the question remains, and the stars continue above us, ancient and calm. As we let go of the story, we can rest in the thought that the cosmos is wide enough for both answers and questions, both knowledge and mystery, and perhaps that is all we need for now.